Hey, Travis and Jesse.
Hey, how's
Hey,
it
what's
going?
up?
I hear you're taking quite a bit more work in the pack stuff, Travis.
Yeah, I'm trying to. That's the plan.
Cool.
It's yeah, I'm hoping to get more consistent. That's my goal.
Yeah.
It's been so
We
sporadic lately.
we were just talking about it in the leadership meeting, so it's good to see.
Cool, yeah.
Uh, and I have to ask you, since this is what I do, what's that I see over your right shoulder there?
Is that a big poster?
No, the bike, man.
Oh, the
Who cares about
bike.
posters? Bikes.
It's
Tell me what you got.
it's an old Cannondale that a friend of mine gave me when I was living in Switzerland, and I don't ride it a whole lot. It's kind of just a fun bike. I have a felt that's a little nicer in the basement that I use.
Which felt? Hey, that's N plus one bikes over there. That's a good look.
It's a F50, and it has
Mm,
some nice Shimano Ultegra components on it that I bought from a friend. It was a while ago, like in 2013. I
wow.
stole it from him for like 200 bucks. So
It's time for a new bike, man.
I know. Right now, it suits its purpose of exercise. I'm not doing any heavy competitions, but I'll need to upgrade at some point.
Yeah. Simon, what do I see as your primary bike there?
I got a. Gotta get my microphone. I got a Cannondale Synapse last year with
Very nice.
it's Ultegra. I think I went for. So
Very
sort of
nice.
mid range carbon. Use it as a commuter mainstay, but also get out for a few long sportive type things.
Mm. What sportives do you do?
So I've done the last couple of New York Centuries.
Okay.
I did the Pride Ride last year. Went up to Poughkeepsie for the Hudson Valley. I did like a
Oh, that must
65
be a good
miler
one.
with that was really nice. Yeah, yeah. Um, and then I had the Gran Fondo, the GFMY lined up.
Hmm.
I've got, but it was cancelled for this year. It was supposed to be the end of May, I think. So
Okay.
I've rolled forward my ticket for next year. So
Yeah. The GFNY does a bunch of European ones nowadays, right?
they're all over. Yeah. They do a bunch of South American ones. They've got one in Sebring in Florida coming up this year,
Don't go there.
which they're still claiming is not cancelled.
Oh, Florida's wide open right now. As long as you don't mind
Yeah.
dying at, New York rates, you'll be fine.
Former New York rates.
Yeah, former New York rates. Fair enough.
Well, we already survived it once. No reason to go somewhere else and experience it again.
Exactly. We're done now. We're not
Damn it.
done. But apparently our number is back up to 1.1, which is alarming.
So I invited someone to come to this meeting today, a user, and unfortunately, oh, there it is. I couldn't find the issue for it. There we go. Okay, let's go ahead and get started. Emily, you mind running it today?
Not at all. Okay. First standing item, introductions. Any new faces here today?
I think you have to tell people to sign in to the document, Steven style.
Oh, I haven't even signed in the document. Everyone's signed into the document. I see a lot of familiar faces, so I'm going to assume that we don't have new faces today. Moving on to release planning and updates. We are preparing, hopefully in the next week, to get 2 spec releases out. To release Buildpack API 03 version of the spec and Platform API 03 spec release. Some of you may be aware that Platform API 03 has existed in the lifecycle for a long time, so its contents should not be shocking because we've all been using it. But once we've formalized that in the spec, we hope to get Platform API 04 out later. There are milestones in the spec, so everyone feel free to take a look so you can see what's going to go out in each spec version. Currently, the plan is to release a lifecycle once we've implemented Platform 04 and Buildpack 03. Javier, I know we just had a pack release. Do you want to give people updates about that?
No, I think pretty much, yeah, as you mentioned, we made the release yesterday. Pack 012.0 has a lot of trusted builder, additional trusted builder commands, and some other changes, more or less, that enable the Docker and Docker configuration. Going back to the lifecycle, is there an expected release for the, or time frame for the next upcoming release of lifecycle? Even a loose one?
I would like to see it in the next couple weeks, but it will depend on getting the spec releases out the door. I think the actual implementation of what goes into those spec releases will be fairly predictable, small chunks of work. So the spec is the wild card there, but I would like to see it in the next 2 to 3 weeks if we can get there.
Cool.
I can see you talking, Ben, but I can't hear you.
Given the bug we found earlier today, Emily, do we want to do a 081 quicker than that, or would you just put off that feature that exploited it?
Well, it depends what that bug ends up being once we actually have time to look at it. There may be a patch release of the lifecycle coming in the near future.
What is the bug?
There was a...
Go ahead, Emily. Sorry.
We managed to break slicing by creating a symlink. Is the working theory right now, but it just came up, so we're going to need to see. Need to nail down the root cause of that. But
you were there, Terrence.
Yeah.
You were literally on the call.
Yeah, well, I'm just playing dumb for the working group.
Oh, okay.
But also, Javier told me to go do something else, which I did.
Okay. Yeah. Depending, so there may be a patch release before then. Okay.
So we're ready to move on to outstanding RFCs. All right, I'm going to share my screen. Okay, starting at the bottom, OS packages. I'm assuming that's waiting for the train of things that are related to it. Most recently, application mixins.
Stack packs? Isn't stack packs the most recent one?
I think application mixins is stack packs.
Should we, like, in the same way we did for CA search, should this actually be moved to a draft so we stop reviewing it?
That was a suggestion I made many weeks ago that got turned down by Steven.
I think for some reason Steven didn't like that idea, but he's not here now, right? Let's just do it.
That's what happens when you go to the dentist, Steven.
Yeah.
Do you just get to make this call when you're in the meeting? You're just like,
Where is the turn it into a draft?
It's on the right
top,
side.
right.
Top. Yeah, it's not very obvious. It's like that plain text under your name. Like on the
Still in
right side.
progress, convert to draft. Down 2 inches, right 1
I'm
inch.
Yeah,
so confused.
below all the reviewer names.
Oh, here
there's
you
like,
go. Okay,
yeah,
okay. Thank you, guys.
they make it real obvious. It's like doesn't even look like
They've
a
Not
made
even
name.
a
a
button. It's not a
thousand
link.
UI. Yeah, they've made 1,000 UI changes in the last 2 weeks, and they didn't do that.
Image exposes metadata for all layers that participated in a build. Actually talked to Paul recently about this. He's formulating a new version of this. I think we can leave it as it is now, but it's going to get closed in the near future, I believe.
Okay. So he's replacing the RFC with a new one?
Yes, I believe that is the case. Root build packs, I think, fall in the same category as this. Do we also want to draft root build packs?
Yeah.
It's what happens when you go on vacation, Joe. Just close all your RFCs.
We did a solid for Joe in the last 2 days. We've merged like 7 of his spec changes.
Okay, next up, stack metadata. This has got 3
I think
approvals.
the only change I wanted was there's the open question about rebasing and how it affects labels. I think that's a actually important point to point out, that it does change a command like rebase. I was just wondering if we wanted that in the RFC. If not, I'm happy to prove without it, but it seemed like an important point.
Yeah,
for
let's.
me.
It's
not a
that
big change.
It's that comment that we're looking at right there.
Yeah.
Okay, I'll fire off to cache it right now.
And if not, like, I'm happy to prove as is, but I figure it's worth.
Yeah, no, I think it's the right thing to do.
It would be nice. It's a requirement for the spec, but it'd be nice to see in the RFC too. Okay, pack image poll policy. I believe Javier changed this to be less controversial by not changing the default poll policy. And it looks like we have enough approvals that we can move this into FCP.
I'll take care of that.
Offline build packages. Is Dan here today? Maybe we can reach out to him because I don't think there's been much activity on this in the last couple weeks.
Yeah, I would like to see this move forward in some fashion. So I don't know if he's just like not interested based on the comments, but it's definitely a thing on the Heroku side we've talked about wanting as well.
I have a quick question for Javier since you're on the call. Today, if I gave you a build package that had multiple layers in it, what would happen?
In what format would you give me that?
In an image?
Image.
Yeah, as an entry in a builder definition, or a package, Tom will even maybe?
I don't think it would work, only because at least the entry point I'm thinking about, we look at the metadata, and the metadata has it so where there's only one like SHA of a layer for a specific build pack.
And how do you handle meta build packs then?
Meta build packs. There's still, the meta build pack still contains all the build packs inside of it. Right, so for every build pack, there is a layer associated to it. And this is going off the top of my head, but I'll have to review.
Yeah, no, that's just off the top of your head. I wanted to know whether it was worth it to try and prototype something like this by synthesizing a build package that was layered up with dependencies and other layers or not. But it sounds like it's likely not to work.
Correct.
Okay, cool.
Moving on to everyone's favorite read-write platform volume mount.
This has fallen by the wayside because of me. I will pick it up again, but I'm not ready to talk about it today.
Okay.
Moving on. Inline build packs. think the outstanding concerns here are there are two. We're just looking at this today. There are two requirements. One to run the build pack, like set CMB build pack dir to the appdir for these build packs, and another one to, if we're not going to have the shebang in the script itself, we need to preserve the shell value. And in the current proposal as it's written, we've sort of lose that information. So I think the overall UX, it sounds like there's consensus on, but we need to figure out how to actually execute those last pieces. Would be my summary. Application mixins is still a draft. Cache scope.
It's on the agenda for today.
On the agenda, we'll skip it. Experimental features. Joe just opened this, I believe. He is not here today. So maybe we will pass over this one for now. But everyone take a look. I put this one on the agenda for today. And pack subcommands as draft. So I think that is it for our outstanding RFC review.
Thanks, Emily.
No problem. Going back to the agenda. Sorry, I muted myself while talking. I'm not sure why. Next on the list is cache types. Do you want to take it away, Javier?
Yes, I can do that. Cool. So more from cache types over to cache scope based on some additional conversations. Overall, I think the idea hasn't really been, there hasn't been a lot of pushback on the idea, but there are some concerns related to, I guess, how it would work, especially the one where it is shared across multiple build packs, or sorry, I should say multiple build runs. And honestly, I don't necessarily know exactly where, like, as myself not being a build pack author per se on a day-to-day basis, I'm trying to understand something like this, right? How that would work, and it requires a lot of mental gymnastics into the explicit implementation that currently exists through a rebuild operation as to how this would operate and function, and how it changes from what it currently is right now versus what it would be if it was shared across multiple rebuilds or multiple build operations.
From what I remember reading of this when you put it up was that that layer is generally going to be shared within like a set of build packs, right? That are working pretty closely together usually. I mean, obviously not always, but if I RMRF, I guess the expectation is that the other build packs would lose it too. Because they're cache layers, right? Like there is also an chance that that cache layer just does not exist, right? And a build pack has to deal with it.
So I get that part. I get the part that like the build pack itself has to kind of acknowledge that that cache layer might not be there, right? Because it could be the first time that it runs. But the question or concern that I'm kind of hearing from this is if you RM a cache layer, what does that mean in regards to this feature in particular? Is the part that I'm losing.
I think my assumption is that it would be gone.
It's interesting though, because you might have a build that then no longer wants that cache layer, but you don't want to get rid of it, right? I think there are some, I like the overall idea and I want us to have something like this. The more I thought about it, the more I think there are some stranger questions, like imagine one of these shared layers is an M2 cache. I put this in a comment today. Right now, the way we restore cache layers is we copy them out of a storage, whether it's a directory or an image, into the layer stir. Now, if a bunch of builds were all sharing the same M2 cache, that might end up being a very large layer, and I feel like there would be performance concerns around copying all that data over. I'm wondering if we wanted to do something like this, do we want these cache layers to behave differently, like they're symlinked in or something, so that they have a different performance profile? That might also make sense on some level. Like a build pack that didn't want to use it could, delete the symlink.
Is the M2 cache the same? It's going to be similar size though across a set of Spring Boot apps though. So wouldn't you want that performance regardless if it's shared or not?
Well, if it's per image and you're recovering it from a cache, the dependencies you're recovering are only the ones that your app used. If instead you have a cache that has the dependencies of every app that ever used the cache, it could get a lot bigger, and you're ending up like it's already a little bit slow to copy layers across, but now you're copying a bunch of things that you don't even need across because you have this shared layer.
So like a concrete example would be something like Spring. You have a Spring app and then you have like a JBoss app, right? With very different big set of dependencies. And we're saying now we're essentially sharing something that is twice the size for what typically would have been just one application's worth.
Or even evolution over time, right? Your application
Right.
has boot 2.0, 2.1, 2.2, 2.3, and on and on.
Yeah, I guess my point is I feel like, though I agree that the performance concerns are more apparent in a shared cache, I also feel that performance optimization is probably a thing that is potentially independent, like an independent concern as well. Like you're going to have apps that also have this use case of like potentially the thing Ben said, unless the build pack potentially prunes the M2 cache, like over time as you upgrade your app, like you're going to have stale things in that cache, right? And it will
This
get
is how
large.
I have a 64 gigabyte M2 cache locally on my computer at the
Yeah,
moment.
so like I imagine the like probably naive / probably the way a lot of people will implement that is like you cache this thing and like it almost seems like that is a different vector. You're just more likely to run into it on a shared cache.
I feel like given our existing cache strategy, the build pack very well could prune the M2 cache every time, which is not something you'd want to do.
Is that what Paketo does today?
Ben,
No.
you're the right person to answer that question.
We don't, but like there's sort of an inherent caching because caches are node local. They disappear pretty reliably, right? To take care of the problem, but we don't actually do any pruning there.
And I wonder, at least for the use case of a pack user, right? If by default this was enabled and you share stuff, but then you get into the scenario of like, hey, you have this like massively huge thing and it's like slowing down, right? I think that's like a maybe day 2 concern or like further along, where at that point you could have other options like, some flag that essentially breaks apart this shared thing to not really be across the entire local machine, but be more specific to some other attribute or none at all.
Like if you think of the way this has always worked, like in CI systems and stuff like that, like they never do anything fine-grained. If you find out that there is anything wrong with your cache, right? It's been polluted, it's been corrupted, it's grown too large, you just whack the cache and pay the penalty to start downloading from scratch again. I don't think we need to be particularly sophisticated on that particular thing, right? We already have a clear cache flag. It could apply to this cache as well.
Yeah, and then I think maybe it goes back to also during one of our other talks where we wanted to provide better volume management within pack CLI anyway. So that could help here as well.
I do think in the typical cache case, though, you're not like copying it across a file system every time you use it. I worry a little bit about that, but I can get over it if no one else is worried.
I do like symlinking, like you were talking
Yeah.
about. Like I feel like that's still like I've done that before where I symlink something in home and also in layers directly, just so that it doesn't do so you don't pay that cost.
Yeah, I mean, I'm not trying to discount what you're saying, Emily. I just think if we should offer that feature, I think independent of potentially the shared cache as well.
Yeah, or could that just be like an implementation detail of sorts within the lifecycle potentially?
Another concern that I haven't raised in this yet, but I'm wondering, is there ever a case, do we want to allow these shared layers to be launch layers? It seems to me like there might be some danger in if a different build could put any old thing in there, then adding it to an image. Should these be mutually exclusive?
I feel the same danger applies to cache layers. That it's very risky once you're talking about once you have to define what apps are allowed to share bits that are definitely coming from the same users to allow you know, a build pack that's building one app that could have proprietary source code or credentials or proprietary language modules to leak into another application and not be isolated from it. But I don't think that applies to just launch layers. I think it's because a cache layer can easily make have bits in it that make it into a launch layer.
So would you advocate for wanting to share launch layers just because the risk is the same as cache layers? Is that what you're saying, Stephen?
So is this being proposed as an alternative to read-write platform volume mount number 85? Or
I think Ben's saying that he wants it in addition.
Whoa.
I said
no, like,
in addition.
I wanted it. Yeah,
that it's like
I'm
a
not
separate
saying
audience.
I want it at all. Yeah.
Like
if we were to accept it, it would be an addition.
Yeah. The reason the cache layers are structured the way they are is anytime that you share a cache, there is possible, like the overriding problem is there's a security vulnerability there. Cache poisoning is a big deal. Cache layers sort of solve this by saying the only thing that can touch a cache is the same build pack over time. And so if there's any cache poisoning to be done, it will be done against itself. The 85 proposal is, well, we're using a shared cache, but you are explicitly opting into a file system that you already own. So if the cache is poisoned, you've done it to yourself in your own application. This adds another layer of complexity where two independent build packs from two different authors can poison one another now. And there isn't a lot of control over that particular security vector.
Yeah, I'm confused by that last statement. So first of all, to answer the question about how these two issues may be related, 85 and 89, is yes, you could do the same thing with 85, but 89, the cache scopes are supposed to be a mechanism that just work, right? So for a user experience perspective, they just work and there's no configuration or any insight needed to know. Whereas 85, you kind of need to know exactly what the implementation looks like on the Buildpacks side of things in order to take advantage of that feature to enable the same functionality. Now, on the other side, platforms additional to Pack could also take advantage of this information to then be able to share information amongst whatever's necessary. Although I hear the concerns that, and maybe we could explore those a little bit further, but I'd see them completely separate. I don't think 85 solves this for the end user at all.
I think the explicitness that 85 requires from the end user helps play down the security debt of allowing us to share bits between separate application builds. That because 85 is just defined for Pack, which is totally local to your machine, where you're a single user, right? It's not something where a build pack can make a decision to share cache layers as a potentially unknown thing to the end user, and you have control over exactly what is shared in that process. Those features of 85 make it, feel better to me. But an argument against, to your point though, a reason I like 85 is that it only applies to the Pack CLI, and it doesn't provide any mechanism for shared caching for cloud platforms like KPack, right, on multi-user things. And that's the reason I like 85. For 89, though, it solves the problem of if you want to do a fast rebuild of a different app on a cloud platform, and you don't want to have to rehydrate M2 cache, 85 definitely doesn't cover that, right? And so there's definitely performance benefit to it. I don't disagree with that, but it seems very risky to me. We've had problems in Cloud Foundry with, there was one time where we due to the way Buildpacks were cached, we shared a little bit of data between apps. In a particular case that led to a very bad security vulnerability. It's like about 4 years
and
ago.
we see the same thing like in CI over the last decade, right? Like Jenkins agents used to just share the file system, and so you'd end up with an M2 cache, and someone would download a snapshot of something, and it would then pollute every single build from every other project on your entire Jenkins instance or Bamboo instance. We saw as well, like shared file systems across applications. Like there's nothing to stop me from writing a Maven build that goes in and writes a vulnerable jar file into a shared M2 cache as a security vulnerability. And now I have compromised every single application that might use that same cache.
I do think the way this is written, though, you don't have to enable the shared caching feature, right? It's only if you've actually passed a shared cache, and the platform is responsible for determining the scope of that. So each platform can make decisions about what it's comfortable with, and expose that risk to the user appropriately.
Yeah, for what it's worth, the way the performance issue that I think this really squarely addresses has always been handled in enterprises around the Java ecosystem, is they just put a squid proxy at the edge, and so every time somebody makes a call for Maven Central, they end up building this giant Maven Central cache with like call it 24-hour expiration or something like that on-prem. So transferring all the data the next time is incredibly fast versus having to go and actually download it over the open internet. So there are ways outside of the builds themselves to address the same thing.
I'm gonna provide an example of how this sort of might work along the lines of what 89 does to just want to sort of ask questions about how different scenarios will work. So say you have two Java apps that are different apps, but you trust both of them and you trust the build packs you're using with them. For one of them, you have using a really old version of the build pack, and one you're using a really new version of the build pack. You generate an M2 cache on one that the build pack opts to share with the other. Now you have a shared cache between the two things. Maybe it's okay that the build packs are on really different versions, but that worries me a little bit because the tooling that's interacting with the cache might be really different, and there's it'll go back and forth between the two. And then I'm not sure how that M2 cache would ever get cleared if a build pack can ever prune it down to just the dependencies of one application, because it would never know that other applications might not be using it. So I think the pruning ability worries me, and the kind of difference in the build environments, things like build pack version, also worry me if we just ignore the security problem also, for some feedback on the sort of logistical stuff.
Is there does the RFC sort of take into account how two concurrent builds using the same cache would reconcile?
That's interesting. So I guess maybe I want to step into, well, no, I guess that makes sense. Because right now they are segmented strictly based off of image name, right? And wouldn't this issue be the same issue if we were trying to use, I know we've had, correct me if I'm wrong, but I think I've heard that we've had an issue where we want to use the same information or the same cache with a slightly different image name, right? Whether you're talking about the latest or a very specific versioned tag. Wouldn't we run into the same issue there, since we wouldn't be able to isolate the cache or the cache volumes based on image name strictly?
People have brought up that when the tag changes, it blows the cache away, and some people want to do a publish with a new tag version every time. And there hasn't been a good proposal for what to do to account for that. But I'd imagine that when we propose something to account for that, there's either an old or a new, or like there's a source start image, and we key, we key the cache on some aspect of the old and new image, so that it'd be difficult to run into that issue. I don't know what happens now though if you try to rebuild with if you try to rebuild the app twice at the same time. Like, do we have race conditions already?
Yeah, that's possibly true. Like, this is the single biggest thing, and I responded to it, I think, to Yael in the original 85 proposal. Like, this is a big deal. Build systems, not just Java build systems, but all build systems generally, just like they can't reasonably concurrently use their own build caches. It's not a thing that they're designed to do, and they react indeterminately when it happens.
Do they basically create a locking mechanism that has to wait for the other one to complete?
Some do, maybe. I think even the Go ones like clone into a repo and then do a file system atomic move, but even that is dependent on the file system doing atomic moves and stuff like that. So like, it's not obvious, especially across multiple different file system providers.
So maybe to step back a little bit and talk about when cache is being shared across multiple build packs, and maybe this is something I should look into a little bit deeper, but I thought the layers themselves were isolated to the build packs themselves. Is that not true, and does that change in this RFC? I don't think I've made that proposal, so I'm not seeing where the different versions of the build packs or different build packs altogether are accessing other build packs information.
I said different versions of the build pack, but not different IDs was my example. Because they're namespaced by ID.
By just ID, not by version. Oh, okay.
And you wouldn't want to blow away the layers anyways, because build pack is upgraded so much that you just never get caching if you didn't at least allow a roll forward. But it's things like now we'd have to support forward, back, forward, back, forward, back on the same layers. Sorry.
Like, theoretically, if you built the same app over and over again with two different builder versions that had different build packs, you could create this problem for yourself right now, but nobody does that.
Well, I'm sure some people do, Ben, sometimes.
You have to go out of your way to do it, right?
We might want to blow away cache right now when the build pack version goes down, so that we're not making a really tough compatibility problem for build pack authors. That'd be pretty easy to do. Just stamp the build pack version that generated the layer on the metadata and then not recover it if the build pack version's older.
Yeah, like this, while it's not a great answer to this question, like the way we handle this already today is we're really, really careful about what goes into these caches, into the very few sort of cache only layer or cache build layers that we do. So for example, like, we fingerprint every single file, right? Like, if we need to cache the result of a build, we have, name, path, whether it's a directory, whether it's a file, a SHA of the files. Like, we're really, really explicit about what constitutes this cache being valid, and almost anything can invalidate those caches pretty easily. But it requires a huge amount of upfront explicit work to do by the build pack author.
So then the security issues or concerns that we're bringing up, they're not specifically about different build packs having access to different other build packs cache. It's more what a build pack does for one application that then can, by mistake, be used by that same build pack in a different context for a different application. Is that the true concern?
Yeah, I mean, like, by mistake is the charitable judgment of this. There's nothing to stop me. So right now, if I manage to get a piece of code into your enterprise that could pollute Spring Core and add some vulnerability to it, that can only affect this application, right? Versus if I can get one in and it's got a shared M2 cache, now I can pollute every single application. I can add that vulnerability to everything in your entire footprint. And that's like for all of the performance improvements you might get, that is a really, really big security vulnerability. And it's why, like, legitimately, we stopped using shared build agents all over CI systems, right? Everything runs in a container these days. Performance be damned, because that sort of shared security vulnerability of cache poisoning is so scary to people.
Maybe the solution for Pack is actually, we could do something a lot simpler than what we're proposing here, which is just that you can name a cache. And then if you're using two different image tags, but you know they're really the same image, you can just pass the same cache in. Like either give like an ID that's not exactly the tag to an image so that we can always give it the right cache, or let people explicitly say what cache they want to give.
See, but that doesn't solve my use case that I have as far as the motivation, right? Like I build a Java app, I build another Java app. I don't want to see the Maven dependencies that are shared being downloaded again without having to do anything. Like I know that's like a pipe dream maybe, but that's kind of like, if it doesn't solve that, then I feel like it's not, like it's just a lot more effort for the end user. And I'm not sure that that's really what I want to drive forward.
Sounds like you want an arbitrary read-write value mount.
I don't, because then you have to say it, right? Like then that's even more complex in my mind. Like I have to be like, okay, so what build pack are you using? Let's figure out how they work. Let's figure out where they want for you to put their M2 cache, right? And then override it using this, thing.
This isn't a thing that Docker files, provide either, or like people in containerized environments aren't used to completely automatically sharing cache, language module between different build containers, or I don't think that's necessarily an expectation of somebody coming into the ecosystem. And so that we allow you to do it, and that it's only a pretty straightforward set of arguments to pass into pack seems like a big improvement on what everybody else is doing, at least. But I get your point about it would be great if the user could be explicit, but not have to maybe if there were a sort of easier way to present that it's an option to them or something. I would definitely go on that. I wanted to just from something I think Ben mentioned earlier, the even if you had like a platform like Kpack where you could say this image is like explicitly okay to share cache with this other image, I would still or you made it very explicit when that sharing happens. I would still worry about edge cases between I think for a build pack author to now think about these, yes, I want to make this intentionally shared, but now I have to think about, oh, this build pack or a different version of it is going to run with a different app and maybe writing to the same location, right? I feel like there are a lot of edge cases there that suddenly make it harder for build pack authors to not make mistakes. And that's another aspect I worry about also. Sorry.
You could also stand up a caching proxy, point everything at it in pack.
Yeah.
I do like your motivation here for I like it as a pack centric sort of local machine, quality of life thing. I do think that maybe a pack explicit option would be nice, and then maybe it can also live in pack config where you have like a cache scope variable of machine or app level by default. So the volumes that pack creates could be machine level by default, and just sort of you deal with the fallout from that as you build from app to app. But it's still explicit, could give you. I don't know about changing it to the default though.
Yeah, I think we explored a little bit of that in the initial conversation that led to this. And I guess ultimately we realized that the build packs are the best, the best things that know and identify what things would be appropriate to share with other things. And that's why we put them in this location versus it's harder to identify at the platform level, right? And then going back to maybe Steven's point where like that expectation might not be there for other tools because other, OCI building tools don't necessarily have it. I mean, the conversations that are here are like people bringing this up, right? Like people saying, hey, like, why is this downloading again, right? So like people do have that expectation that stuff, they don't expect these things to re-download again. And it's maybe because they don't understand what's really happening behind the scenes, but in some regard, I don't think that they should, right? So with all that in mind, I'm curious about the, proxy. I think that'd be an interesting solution that would be pack specific. The volume, the named volume cache is also interesting, although I think that one seems a little bit more, there'd be a lot more thought process needed for that one.
For those issues that users have brought up, are they instances where users are expecting different apps with different source code to share dependencies, or is this the tagging problem where they want to make a new app with a new tag and they see it gets re-downloaded and they don't understand that you have to use the same tag, which is admittedly a confusing thing. Because I think that makes a really big difference, because I'm much more comfortable saying that like we should fix the tagging problem in a really seamless way, right? Than I'd be saying we need to share dependencies between completely different applications.
Yeah, so like if we look at this one, right, this is from Dr. Nick very early on. And from what I read, his expectation is that it'd be like this Go compiler dependency should be downloaded only once across multiple applications.
Across different images being built. He says different images being built, but does anywhere in there he would say multiple different applications? It wasn't clear to me for this one. I think I did see this a while back.
You did respond to it after all.
Yeah, and then this other person here, right? They kind of pinpoint a couple different things, but this was one of them that I read into here, right? So if I do app v1, app2 v1, they use the same code engine, few lines difference. Why do I have to recompile everything? He goes into a little bit more abstract, but this is kind of what I'm gathering from it as well, is that a lot of stuff is being redone, or essentially could be reused if they're, for the most part, exactly the same.
In the case one, he talks about he's talking about different versions of the same app, right? In the case two,
Right.
he does say same code engine with a few lines of difference, right? So it kind of implies it's the same app, and he's building it a little bit differently, right? But that's also not clearly the same. Like if it's different build parameters to generate a different image off the same source code, I don't feel as bad about that, right? I have to think about that more, right? But I don't see two apps with completely different source code mentioned in this one. And that's the case I worry about the most, right? When they could come from different places and poison each other.
Yeah, and I think I'm putting myself in the shoes of the app developer, right? And the experience that at least a few people have mentioned from what I hope is their perspective. And I guess we could dive deeper and by asking them exactly what they're trying to do. But this is what I would expect as well as an app developer without knowing exactly what's going behind the scenes. If it tells me that it's building something and then it's able to recognize that this other thing is very similar to the thing that I just built, I don't expect it to have to download and redo a whole bunch of operations.
I mean, or I guess here's an example of the type of interface maybe that I would be more comfortable with that would solve both of these problems mentioned there. Say in Project Toml, you have an ID and a version, right? If your project ID doesn't change, you always get the same cache, right? And that way, as a user, you're explicitly saying, nope, this is the same source code, right? Even if you're picking a different image location, right? And so you could have app one and app two in case two have the same, application ID because of the same source code, and you're just building it in different ways, right? Building different artifacts off the same app. And that would solve case one and case two without introducing a security vulnerability because the user is being explicit about, hey, yes, these are the same. It's okay to share data between them.
The other thing that kind of hinted at something like this, and I don't know exactly how related it is the offline build pack, where it was explicitly saying like, hey, this is a dependency I have, and this is where I'm going to go get it from. And because it had essentially an itemized list, I could see where that could be shared across in different application scenarios. I don't know if that's...
The other justification for that was those caches are read-only, effectively. They're packaged inside during build time and then are only ever read from, so there's no cache poisoning issue there.
Build pack build time.
Yeah, build pack build time. Sorry, thank you.
Yeah, so I wonder if we piggyback on top of that to solve this problem as well, if that would be a solution, because that would solve this scenario, right? At least the one that Dr. Nick brought up.
Yeah, in Dr. Nick's case, he's talking about Go itself being downloaded, and that
Yeah.
actually would be totally solved by Dan's RFC about offline build pack packaging, because you could package the build pack with Go, right?
Yeah.
Maybe a way for, maybe you could introduce a lifecycle step that would like run some partial packaging on the build pack of a pre-built builder, and so you could cache your builders dynamically, or using a volume or something like that. I could see a hybrid thing there that would be safe to do, where it's not exposed to the app code when it's doing it, and so it's safe even though it doesn't have to happen all the way at build pack packaging. But it doesn't solve for language modules or particularly large things, just the runtimes and compilers.
Yeah, and I guess I maybe also want to go back to the dependency cache poisoning thing, especially in M2, right? So when we talk about if the project ID didn't change, then you could reuse the same cache as that. But then I think about M2, right? And we're essentially, at least from Pack's perspective, within the same domain, right? Local machine development, building stuff. So the same problems that would appear for Pack and this feature would also apply to M2, right? Or Maven in general. Is that not true? And is that a risk something that's been already taken?
It would be true, but the big difference is in 85, a user explicitly opts into that security vulnerability, right? Like they have decided that they feel enough control to do this thing. Having it as an automated feature, it means that a user isn't sort of like every time they do a command signing off that they understand the security risks that they're doing here. And that is in truth an absolute direct opposition to the goal that you have. You want users to not know that it's happening, which is a worthy thing. And 85 is designed to require a user to know that they're about to do this dangerous thing.
Yeah. And I advocate that like 85 is more than that, right? It's more complex than that, depending on the build pack and how the build pack implementation requires that information.
Oh yeah, but I mean, like, it's a documentation issue, right? Same as environment variables for configuration, right? Here, you want to share an M2 cache. In the README, it says use this -- volume, ~/.m2 : ~/.m2.
Where would that documentation live? I guess maybe that's the problem, because I don't see how Pack or the Pack project itself could direct users to do that for any particular
we display the build pack home pages, right, where people can then go look at the build pack documentation. There's a lot of things you can't do with a build pack without looking at its documentation.
You could put it in the builder description too. Sorry, go ahead.
Let me also, do you mind if I do a quick share, Javier? So one of the things that we have taken to doing in the build packs to help with all this, you can do a Docker inspect, obviously, to find the URLs, but the Paketo build pack specifically put in not only their URL, so you know to go look at it, but we also describe the build configuration every time you do a build, whether we use it or avoid it or what have you. If you set a value, we put that kind of stuff. So like build packs could write, right? The next line in here could say, hey, and if you want to share an M2 cache, here is how you do it. There's nothing to stop a build pack from providing the documentation that it actually wants.
You could even tell that M2 is not a volume and output it only in the case that it's not a volume. So say hint, sure. If you're doing a local build, we notice this isn't shared. You could share it if you want to, like this.
Yeah, like you're absolutely right, Javier. Pack should not be responsible for getting this kind of documentation out. It's up for each build pack to encourage users either to go and read the documentation, won't happen, or display the documentation in line. Might actually see that.
See, I guess the problem with that though is that then it's very tied hand in hand between Pack and the build pack, versus the build pack obviously runs in like Kpack or any other platform, right? And I don't see how they could directly talk about each other in a sensical way.
Yeah, I'm not sure I do quite the documentation, but as that. I would probably push it off. Like the environment variables, I think are okay there. I would push documentation about sharing a volume out because again, like in the default case, I don't want any user to do it, right? Like even with Pack, I don't think everybody should. I think you should just pay the penalty of downloading it. But in the case where you want to, you are highly motivated to read some documentation.
I do think if you're talking about the same source code though, and the thing that's varying is just the app tag or some environment variables you're feeding in at the beginning, I'm all for, which looking through the GitHub issues, it seems like the general trend of what people are asking for, I'm all for making that very seamless and providing a bunch of different ways to ensure that you do get the cache back when you're building the same thing.
Yep, absolutely. I cannot concur enough. That is something we should definitely have an RFC for, is to make the requirements, the definition of what is reusable, what is the same thing, make it coarser than it is today. Yeah.
And
the good thing is I only build latest, so it's fine.
It could look really different for reusing launch layers of the previous version of the app versus reusing just build time cache layers too. We could have configurability in that so that you don't get the go runtime twice, but there's no chance that you reuse a version of the binary that was built with a different flag that's in the image, right? Different environment variable.
I guess I'm having trouble understanding what that would look like or picturing what that would look like. So I don't know if anybody has any ideas where they would be able to propose an RFC for a solution to that. But I feel like the demand has definitely been there from a user's perspective where they just want things to perform faster, right?
I totally agree with solving the problem, if that makes sense, and making it easy to do. It just
this might not be the solution. I totally get that. Yeah.
Or it's complicated. Like it's a very hard problem that we've talked about since the beginning, is how do we really maximize caching and make builds as fast as possible. And so it's an important goal, and we should do it. It's just a complicated thing. If that makes sense.
Sounds like we're wrapping this one up, and given that we only have 2 minutes left, I'm going to say we should probably punt the rest of the discussions till tomorrow.
Yep. Thanks, everybody.
All right. Have a good one.
Yeah.